In 1989, the Tectonic Studies Group held its 20th annual meeting in December at Imperial College. Back then, the annual meetings were always held in December, which gave them an end of term or party feeling. Participants may choose to forget a rather unfortunate incident that involved a halibut. But the meeting itself had some 56 unsolicited talks, 20 of which were given by overseas speakers. Topics covered subjects such as Himalayan tectonics, right through to sedimentary basins, the geometry of normal faults, fluid flow in accretionary prisms, salt tectonics, a great range of topics. Mike Coward, the organiser, chose to devote the final session to a future-looking Quo Vadis session. Two of those talks were given by industry. The 1980s had been a decade that saw considerable change in structural geology in the UK. My name's Rob Butler, and I'd like to take you on a journey through that decade from a personal standpoint. In this, I play a sort of Forrest Gump-like role because I was fortunate enough to be at many of the really key meetings, and I've got a series of memorabilia that will help me remember some of the events, from abstract books from the annual meetings and the regular series of specialised meetings that happen during each year. Some abstract books on workshops such as the Deep Geology workshop and the Moyne meeting, together with the formal collections of papers that resulted from some of the meetings. Well, my first TSG was at Nottingham in 1979. So if I look at the contents of this, I can remind myself of some of the topics. Most of the geology was concerned with orogenic systems, outcrops, trying to characterise rather complicated deformation and to quantify strain patterns. For many at the meeting, I think the only good fossil was a deformed fossil, particularly one that could be used to quantify strain. So how do we get from topics in the 1970s at Nottingham to the diversity of topics that were being considered at the Imperial College annual meeting? Well, the first person we need to introduce in this story is Dave Elliott. Dave was a Canadian and in the 1970s was based at Johns Hopkins University in Baltimore, but he had strong links to the UK and had been a research fellow with John Ramsay. But he worked in the Canadian Cordillera in the foothills in Alberta and brought the understanding of thrust systems from that region to the UK, introducing the community to the concepts of section balancing and general structural analysis of fault systems within thrust belts. And it revolutionised the way in which we think about thrust systems. I guess in the late 1970s, the general view was that the large-scale structure of thrust belts were established and we understood how they worked, and structural geology was concerned with measuring strain to establish patterns of deformation that could be used to evaluate emplacement mechanisms. But Dave showed us that we needed to understand cross-section scale evolution. Well, the next person we need to introduce now is Jake Hossack, and Jake essentially played a role that was as Dave Elliott's agent, if you like, within the British community, and he developed a series of section balancing workshops that he shared through TSG and with seminars in various universities. I was fortunate enough to attend one of these as a student in Leeds. Which brings me to the next meeting. In March 1981, Graham Williams ran a meeting on strain in thrust belts at Cardiff, which is where he was based at the time. I was on a final year field trip run by Mike Coward to southwest England, and he took a bunch of us to the meeting. Mike was one of those working on strain in thrust belts, along with people like, well, Jake himself and Graham Williams, Rod Graham, Mark Cooper, Alistair Beach. And thrust belt research changed from being obsessed with outcrop and strain to worrying about the scale of cross sections. Two meetings in 1982 illustrate this. On the 5th of May, Mike Coward ran a meeting on the construction of geological cross sections that was co-sponsored by TSG and the Joint Association of Geophysics. Talk started with geophysicists Martin Bott on gravity, John Brewer on the BURPS programme and deep seismic reflection profiling, then John Ramsay on isogons. But there then followed a set of papers on section balancing. Well, the following week there was a meeting run in Wren by Peter Cobbold and colleagues on strain patterns in rocks, and many of the speakers at the London meeting were also speaking there in Wren. So we jumped into a minibus and went to northern France on the way to pay homage at one of Jake Hossack's exercise locations, the Hainaut-Basse-Normandie duplex. This important site has largely been shotcreted over, and it's a real loss. Suitably inspired, we then continued our journey to Wren to think about strain patterns. During the discussions at the end of each day, participants gradually drifted away to the bar across the street to discuss the new ideas about thrust belt structure. This generally left Peter Cobbold and Dave Elliott, who was a pioneer in strain himself, discussing the ins and outs of strain compatibility and tensor notation. As the Wren meeting progressed, many of the speakers changed what they were to talk about. Rather than speak of strain in outcrops, they spoke about the importance of understanding cross-sectional scale geometry and balancing sections. Well, in fact, of course, section balancing is all about strain compatibility, of making sure that the deformation matches layer to layer on a cross-section. Dave Elliott passed away in 1982 on the way to the Lines and Planes meeting in Zurich, but he left structural geology, at least in the UK, has fundamentally changed by introducing the concept of balanced cross-sections. The write-up of the section balancing conference was dedicated to the memory of Dave Elliott. This was the start of the thrust belt revolution, and it showed the importance of faults and understanding fault systems if you want to understand deformed rocks. Well, these ideas brought more students into TSG. At the annual meeting in Glasgow in the winter of 1983, well, it was hugely oversubscribed, and remarkably, Graham Williams, the TSG chair at the time, was able to put together an overspill meeting in a matter of weeks, so that in the 1st of February 1984, there was a meeting held at the JOLSOC that was also had a big component of thrust tectonics in it. Though, of course, the big meeting of 1984 was the Thrusting and Deformation meeting held in Toulouse and run by Joe Deramond and colleagues. The write-up is in the 1986 issue of Journal of Structural Geology. The meeting itself had way over 300 participants, drawn internationally. So thrusting was big in the UK, but it was also really big internationally now. But the early 1980s weren't just about thrust tectonics. In the late 1970s, the Consortium for Continental Reflection Profiling, COCORP, began to acquire deep seismic reflection profiles through parts of the US, the most influential of which was probably the ones shot across the Appalachians that revealed thin-skin thrusting. Well, the UK were quick to pick up on this and established the BERPS programme, the British Institutes for Reflection Profiling Syndicate, and they established a programme to profile the deep structure of the British calidonides. Their first line was MOIST, the Moyne and Outer Isles Seismic Traverse, and this was acquired in 1981. So it was time for structural geologists to work with geophysicists, and TSG were there at the start. In December 1980, TSG and the Student Society at the University of Leeds ran a meeting on the deep structure of the British calidonides. It brought together structural geologists and geophysicists, most particularly Dave Smythe from the fledgling BERPS group, that presented the initial plan for the MOIST line that was acquired in March the following year. The BERPS programme was important not only because of the profiles it acquired, but also it brought together, at least in the early days, the structural geology community and the geophysics community. It did this through a series of deep geology workshops run by NERC and also a really remarkable field excursion led by Derek Flynn and Mike Coward in 1983 to the Shetland Islands. This field workshop allowed structural geologists and geophysicists to debate the nature of seismic reflections and the ways in which continental crust can deform. Here we see John Matthews talking with Derek Flynn and Mike Coward on the 3D geometry of deformed conglomerates, though quite what that tells you about the geometry of seismic reflections is of course open to debate. But the big thing about the BERTS programme is it moved structural geology offshore. Their data were marine, and suddenly the focus changes to working on sedimentary basins. In thinking about sedimentary basins, structural geologists have been rather slow on the uptake, but actually the whole world had been. I guess the starting point is probably Dan Mackenzie's classic 1978 paper, Some Remarks on the Development of Sedimentary Basins. And this had passed people by. That was until the 1981 William Smith lecture on the plate tectonics of the British Isles. This lecture was due to be given at the Geological Society, but it was hugely oversubscribed and actually took place at the Royal Institution. The speaker was John Dewey, and he opened our eyes to the ways in which we should understand basin systems. By showing us the work that Dan had published, he showed also that in order to understand sedimentary basins and to quantify substance histories, we needed to use stratigraphy. And strain parameters changed too. It was no longer about 1 plus E, but it was all about beta. Well, of course, the Mackenzie model is a thermomechanical description of how the lithosphere deforms. It doesn't aim to explain how the continental crust itself faults to accommodate that stretching. This became the next big thing within TSG, and it ran a critical meeting on the subjects, the Continental Extensional Tectonics meeting at the University of Durham in April 1985. I was a research fellow at Durham at the time and ran the projection for the conference, the biggest hassle of which was organising the facilities so that Ken McClay could show a cine film of one of his early sandbox models. Anyway, the write-up of this conference is in a really classic special publication of the Geological Society, Continental Extensional Tectonics. Most of the papers are on land examples of rift basins, particularly the basin and range, together with some theoretical models for stretching, and there were a few talks from Burps and Cocorp, particularly Cocorp's new basin and range profile. There were also comparisons made between the contrasting styles of basin and range tectonics and the stretching in the North Sea. But there were rather few talks about the specific geometry of normal faults themselves. Now, TSG had been debating this topic as well through the early part of the 1980s, and I guess the first important meeting of that was the one run by Alan Gibbs at the Geological Society in January 1983 on the structural geology and microtectonics of the continental shelf of northwest Europe. You can perhaps appreciate Alan's thinking at the time from the diagram on the front of the abstract book, which shows normal faults as fully linked systems, owing a lot to the ideas developed in thrust belts, more or less at the same time. In the early 80s, both Alan and Alistair Beach were at Britoil and were really influential in developing ideas about how the North Sea stretched at the time. And of course, Alan went on to start Midland Valley exploration and develop early software for reconstructing the fault geometries and the geometry of rollover anticlines, which became a bit of a thing through the 1980s in various parts of the TSG community. The idea that normal faults in the continental crust were listric was highly debated in the 1980s, and some cynics pointed out that many of the places that the faults went low angle were just below the limit that the seismic stretched to. And there were other ideas in play, particularly the concept that faults were planar and that the rotationals could be explained by isostatic consequences of movements on planar faults. Dave Barr at BGS and then later Britoil and then later BP pushed those ideas fairly considerably and underpinned some of the ideas that go into the flexural cantilever models developed by Nick Kuznier somewhat later in the decade. Another key player, of course, was Stuart Watterson from Liverpool, who showed, by working with the Coldboard and their data, that normal faults show smoothly varying and predictable displacement patterns. He took those ideas subsequently to work onto seismic data, and this became really influential in providing quality control on structural interpretations in these subsurface examples. These ideas were presented to TSG, but they were also presented at a major meeting towards the end of the decade, the geometry of normal faults, run by the Baddeley's team of Alan Roberts, Graham Yielding and Brett Freeman. And again, these led to a classic special publication, The Geometry of Normal Faults, published a couple of years later. So we've almost got to the end of the decade, but it's worth reflecting a little bit about how the participation at TSG has changed. Well, we've just seen that the normal fault debate was initiated, at least in part, by Alan Gibbs and Alistair Beach when they were at Britoil, and industry began to play a big role within TSG through the 1980s. This is perhaps exemplified by the role of BP during this period. Now, BP had actively recruited many of the important players in the early days of section balancing, at least within TSG. They'd recruited Rod Graham, Jay Cossack himself, Mark Cooper, into the Structural Studies Group that was run by Ian Vann. Now, that community didn't just disappear into industry, they were an active part of the academic debate about structural geology, and indeed initiated one of the major important things of the later part of the 1980s. Mark Cooper and Graham Williams organised a meeting on inversion tectonics, a Tectonic Studies Group meeting held at the Royal Society in March 1987. And it led, of course, to a classic special publication of the Geological Society on inversion tectonics, published in 1989. So in the 1980s, TSG had become a community of both academic and applied geologists working on very similar sorts of problems. And we can get a feel for this if we look at the programme for the Hull TSG held in 1986 in December. There was a whole session on Burp's imagery and interpretation. John Walsh and John Watson spoke on displacement geometry around a single normal fault. Of course, there were talks on thrust systems and studies from all over the world. The early afternoon session on day 2 started off with a talk by Rick Law, Jeff Lloyd, Martin Case and Stefan Schmid on electron channeling and X-ray goniometry. But at the end of the session there was an invited address about access to seismic data from John Brooks, Head of Exploration at the Department of Energy. Because many people at TSG were trying to work on the geometry of fault systems and the extensional basins, Donny Hutton, the then TSG chair, invited John Brooks to the annual meeting to discuss ways in which the community could get better access to seismic data. In this, he was following up an initiative, rather curiously, that was proposed by Margaret Thatcher about trying to get academics and industry working more closely together. So that's what Brooks was missioned up to talk about. This didn't go particularly well, because Brooks basically said that he felt that the academic community were not equipped to interpret seismic data. Well, this did not go down well. Many people, particularly John Watson, were apoplectic. Well, reflecting the mood of the mob, Donny, as TSG chair, wrote to Thatcher and said, "Is this what you mean by better collaboration between industry and academia?" This did not enamour TSG to John Brooks, and it took the efforts of Rob Knight, who then became TSG chair, to smooth the waters. In fact, this didn't lead to better seismic release. Although we had the access to the data, the management company responsible for releasing seismic data charged the cost of reproduction for anybody wanting access to it, which became prohibitive. But those of us who wanted access to seismic data simply wrote to our industry contacts. It didn't increase access, but actually TSG as a whole worked with seismic data a lot from there on. So let's go back to where we came in and the journey from the TSG in Nottingham in 1979 to the one at Imperial College a decade later. The distinction between academic research and industrial application had been blurred. This societal use of structural geology remains a distinctive feature of TSG to this day, and it's a real strength. Secondly, the thing that strikes me about the 80s was the sheer number of meetings that took place. Just take 1982, for example. These meetings, I attended all of them and also managed to do maybe 4 months fieldwork in that year, were enormously important. Today, some people complain about the sheer number of meetings in the scientific calendar, but I think it's a real strength. The opportunity to talk with other scientists, to actually share ideas, is a really important part of the creative process, and I think you lose that opportunity relying on the mega meetings that are currently in vogue today. Finally, the 1980s shows the dangers of future scoping. In the late 1970s, I think structural geology was frankly a bit niche. It treated the description and quantification of deformation as an end in itself. For many, stratigraphy was little better than stamp collecting. By the end of the 1980s, this had all changed. Sedimentary basins were in, and structural geology played a fundamental role in understanding how they worked. So structural geology and TSG was making a societal difference. It blurred the distinction between academia and industry and worked in collaboration with other earth scientists to study complicated tectonic systems like sedimentary basins. And TSG's not looked back. Here's looking forward, though, to the future decades of stimulating research. I've been Rob Butler. I hope you enjoyed this rather crazy journey.